Welcome to Ask and Learn.
For this problem, we are looking at a solid. Now, the base of the solid is a triangle. It has the vertices 0, 0, 1, 0, and 0, 1. So I'm just going to shade in red. This is the base of our solid. Now, we're also told if we take cross sections perpendicular to the x-axis. So perpendicular to the x-axis means I'm taking little cross sections just like that, perpendicular. And these are squares. So you can imagine that I'm going to just be stacking squares all along the x-axis. So I'm going to go from x equals 0 to x equals 1 all along. So I'm finding the areas of squares. Well, this area of squares, I'm going to get rid of that s in just a minute, but it's going to be the side squared. That's the area of each of those squares. And the height of them is going to be that infinitesimal change in x. Okay, so this is my basic setup. Now, I don't want to leave the s in there. I want to make the side I want to put that in terms of x. So let's take a look at our picture. My value, the height of this is going to be the value of that line. As I'll move along that line as I go from x equals 0 to x equal 1. So what is the equation of that line? Well, I can see just by examination, the y-intercept is 1. Well, what's the slope? I'm going from 0, 1 to 1, 0. That's a slope of -1. So that is y. That's the height of that curve, that line as I go across. So on my integral, I don't have an s. What I can do is I can say this is -x plus 1 squared. So let's square this. That gives me x squared minus 2x plus 1 dx. Okay, let's integrate. We can take the integral of each piece in turn. This gives me x cubed over 3 minus, well, that becomes x squared divided by 2, so that cancels the 2 that's already there. So it's just -x squared plus x. And again, I'm integrating this from 0 to 1. So upper limit first. If I put in a 1, I get 1/3 minus 1 plus 1. If I put in that 0, well, every term is 0, so I can kind of ignore that piece. And when it's all said and done, the volume is 1/3.